Accurate airflow measurement is the key to proper HVAC commissioning. Today we're breaking down why flow hoods matter, why accuracy makes all the difference, and how the Flowfinder's unique design helps eliminate confusion and guesswork when balancing and testing ductwork. Today we're talking flow hoods. Now, not all flow hoods are the same. Is that right, Nick?
Well, yes, that's absolutely true. No flow hood is the same.
Yep.
There are many different flow hoods around.
Yep.
For many different applications, but also of different quality and accuracy.
Now, one thing that I've noticed from flow hoods that I've seen, and usually they come out for commissioning duct systems and plenums and just airflows coming out of things, is that they're always sort of restricted for the flow that you're trying to collect. They always come down to a sort of narrow spot where the airflows are actually captured. And I can see that just by that happening, how that can potentially have an effect on the accuracy of the flow.
Oh yeah. That certainly is a thing with flow hoods. In fact, when you put a flow hood on a ventilation system, you are extending the ventilation system with an extra duct, so to say. And ducts, they do have resistance. And if you then have a duct which goes from a large size to a small size, this is the grill, here is the flow, and then you can imagine that it is as if you are putting your hand on the duct and the flow is going somewhere else. Putting on a resistance in the system.
So how far out can the flow be when we're using flow hoods?
Well, let's assume that you have a properly calibrated flow hood, and then the word properly is, of course, you have to define it a little bit. It is calibrated on a certain system, and every system is different. So if you match the system on which the flow hood is calibrated, it will be within specs for sure. But that's almost impossible because there are so many grills around, and there are so many different resistances and systems around, that a standard flow hood can easily be off by 20% or more, depending on the flow pattern. You have to sort of know what you are doing. So if you know what you are doing and if you know how to correct for this, maybe you can get away with a simple flow hood. Otherwise, you really have to know what you are up to.
Because depending on the runs, you will get different velocity of air coming from ducts or duct openings that are closer to the air handlers too, right? So the way the air comes out of an opening can vary where it is in the duct run.
It can vary where it is in the duct run, and it can also vary because just behind the grill is a vent. If you have a vent, the air accelerates in a different way, and it doesn't come out like this. But on this side of the grill, the velocity will be higher than on this side of the grill.
On different sides.
And if you have a standard passive flow hood, we will explain that later, then it doesn't understand the velocity pattern, and it makes a measuring error.
Can we demonstrate here? This is a beautiful calibration rig that you guys have here on this effect, comparing it to just a normal flow hood that doesn't have any.
When we talk about this is for normally for residential. And often these kind of grills are used when there is a heat recovery unit in the house. So you will be getting into like really airtight houses, passive houses where they use this. As you may see, this grill, the flow comes from here, from this little
around the side.
So it throws the flow
and
away
to the side. Gotcha.
To get a nice covalence effect. And that makes it quite hard to get a good measurement. So Acin makes the Flowfinder since 1980 something.
Wow.
But now since 2010 we have a real digital version, and we just upgraded it with more nice features and better efficiency, but that's a powered flow hood.
So it's almost like a mini blower door, but it's just there to pressure neutralize air coming from ducts.
Yeah, that's what it does. You put it on the grill. The Flowfinder measures its own resistance, the pressure drop over the Flowfinder, and then starts running a fan. Like with a blower door. A blower door you would control to, let's say, 50 Pascal or 10 Pascal or whatever. The Flowfinder you always control down to 0. When it is at 0 Pascal, the rotation speed of the fan gives you the flow. That is because it is calibrated on this rig. We make a table in the Flowfinder with rotation per minute at 0 Pascal resistance over the Flowfinder. And if you have a passive flow hood, you can't do that. You have all sort of resistances. So your rotation per minute may be the flow, but it's only the flow with that passive flow hood on it.
Yeah. So it's more important to have this pressure neutralization for the higher flows.
It's more important to have the compensation when the resistance of the system is low.
Ah, right.
Suppose this one, the pressure drop over such a grill is quite high.
Yes.
Now I'll take it off.
Yes.
The pressure drop over such a hole
very low.
Much lower.
Gotcha.
And the pressure drop over this is even lower.
Gotcha.
So if you put a passive flow hood on such a hole, an open hole, low resistance, then you get a huge error.
Right.
So this is the flow at the moment.
Yes.
Coming through the tube.
Yes.
I'll put some resistance on it.
Yep.
Top. There it goes. Flow goes down. And now I put this one on. So now the flow is even lower.
Yep.
But now I put a passive flow hood on. On this one, the effect will be small. But on this one, the effect will be very large.
Yeah, gotcha.
And with the Flowfinder, it doesn't matter. Either this one, it measures this one properly, and it measures the open hole properly. Cool. So it does a whole range of resistances and grills without pain. A normal flow hood does a good job on many systems, but you never know where and when the deviations are. And then there's another problem. If you have a supply exhaust system, then the supply is more difficult to measure than the exhaust. And it has to do with the fact that with exhaust, the flow comes in the back of the measuring unit of the instrument, and that's always the same.
Yeah.
The flow pattern coming from the back is always the same. But with supply, it comes out of a grill like this, or it comes out of a hole, and that's all different flow patterns. And your sensor, your instrument, has to account for that in a way. And then the Flowfinder has a grill that breaks up the flow and then starts compensating. So it's not so much influenced by the flow pattern. So there are two things, flow pattern and resistance.
And your Flowfinder solves both issues. It cleans up the air and it pressure neutralizes it. And it's even worse when it's in positive pressure because you're trying to smash all this air into a narrow channel, and it's not really how it behaves when it's just open to air as a grill.
The flow pattern problem is the biggest with supply flow. The resistance problem is both similar for exhaust and supply flow. Because if you have to push it through a hole from the back or from the front, doesn't matter, there is resistance.
So Nick, can you demonstrate how the airflows can vary with these different flow hoods? With your beautiful Flowfinder.
Let's first start with the Flowfinder.
Yes.
And here you have a screen. I don't know how well you can read it, but the most important thing is here is the differential pressure. And the differential pressure is measured in the hood with these pitot tubes against this hole in the back. So differential pressure outside, inside.
Cool.
Supply flow, you will get a positive pressure in the hood. Exhaust flow, you will get a negative pressure
in the hood. And this is the battery.
This is the battery.
And the fan inside it can operate either way, negative or positive pressure.
You will see the sign of the pressure will give you the direction of the flow. But it will also tell you.
So you're putting it over the top of this airflow here from the calibration rig.
And we now have a flow where the fan is already rotating based on the passive measurement.
So you have not activated the onboard fan yet to equalize the pressure inside.
No.
And you've got a pressure in here, 7 PA, 6 PA.
6 PA.
And then
you press the button.
You're going to turn that to 0.
He is sort of looking for the 0 point. There it's speeding up and it's already getting close to 0.
Wow.
And now it needs to take a few measurements of the rotation and it gives you 80 cubic meters per hour.
Let's do that on another unit.
So here we have a simple anemometer and a hood, no pressure compensation.
It's just a fan, right?
Just a fan. Look at the flow, it goes down. So it's building up resistance. And it measures a proper flow because it's measuring the flow with the hood on it.
Of course.
And it's giving you 67 cubic meters per hour, which is like 13 cubic meters per hour lower.
Oh, wow.
Which is almost 15%.
It's significant. Okay, so now Nick, commercial. This is a big market. This is a perfect place to be using the Flowfinder. We're looking at a commercial grill here. How much flow can you measure?
We can measure up to about 200 liters, 250 liters per second.
From a grill?
From a grill. That's not yet as big as they can go. The commercial grills sometimes do 1,000 liters a second.
Yeah.
We can't measure that. But the usual grills in schools and offices, we can easily measure.
Yeah,
in
of
hospitals.
Of course.
You can hear already from the tunnel there is more flow. Now the flow finder is running already. When we push the button, also look at the cloth. The cloth is very tight now.
Yeah.
And when it starts compensating, it will go back to its original shape. See, there goes the cloth.
Wow.
Because it's pressure compensating.
Yeah.
And it's zero pressure now.
Yeah.
And this is 85 liters per second.
Wow.
And you see how fast it does it?
Yeah. Conventionally, how does this commissioning work in the commercial space when they're trying to line up the airflow from the air handler through to all of the outlets?
What they normally do, they're not sure about the accuracy of their flow hood, or they know that it differs on different systems. They are all experienced commissioners, so they do a good job.
Yeah.
But they have a hard work because they first have to measure the total flow of the whole unit.
Yes.
They often do that with a pitot tube. You can already make easily 10, 15, 20% error with pitot tubes.
Yes.
If you don't do it properly, and not everybody is educated to do it.
Yeah.
And then they start measuring all the grills, and they add up all the grills. Compared to the total flow, there's always a difference. Let's say it adds up to 1,000, and the total flow was 1,200. They multiply all the grill volume flows with 1.2. As you know, in flows like for an orifice, you have a so-called K factor.
Yes.
And they call it a K factor, so that the 1.2 is the K factor.
Okay.
And in my view, that's a fudge factor. I don't believe in that. Well, we've experienced, especially in the US, it has been shown that in many commissioning jobs, they had a good system to measure the total flow, and they tested it against the flow finder, and the flow finder and the total flow were in agreement. So our fudge factor is 1.
Wow.
Which is what you want.
Yeah, absolutely. I mean, you just don't need to try and predict where some air may or may not be coming from, right?
Well,
I mean,
you even have a much nicer application.
Yes.
If you believe in that 1, I do, and the factor is not 1, then you have leakage in your duct system.
That's true too.
Unless you have a total volume flow which is higher than the sum of the flows.
Yes.
But that hardly happens.
Yeah, of course.
Again, as an example, the US. In the US, the residential flows are already quite high. And there are commissioners there that actually use the total flow measurement and the flow finder to estimate duct leakage. And if they have a lot of duct leakage, they start looking for it.
That's interesting. Because duct leakage is one of those things that we all hope don't exist. Yeah. But in reality, it's actually quite prevalent.
So, John, absolutely great that you visited our calibration room in our company. Thank you for coming. And I'm very glad that I could show you where, in my view, the advantages are for this powered flow hood against other flow hoods.
Absolutely.
And it's not a matter of saying those other flow hoods are bad or ours is good. It maybe is a little bit like that. But it is way easier to get a consistent measurement between different projects. Yeah. That's what we try to offer and to bring with the flow finder.
It's an absolutely amazing product. So yeah, well done.
Yeah.
Well done.
Thank you.